No. All right. Hello, everybody. Welcome to Python or PyOhio 2013. I'm Michael Yanovich. I'm presenting on Python 101. It's current tutorial / class / I don't know, any other name you want to call for it. But the idea of the class is to bring you up to speed on Python, at least get you started with it, have you learn something new, hopefully, even if you're a complete beginner or if you're someone who's been using another language and you're trying to make the effort to go to Python. A few things about information that's going to be presented in the class and about myself. I have what I call like pre-built notes, which you can grab at my public GitHub's gist. Let me create a short URL for this, which, yeah, so if you go to git.io / this random sequence, you'll pull up the generic notes for this. You don't absolutely need these, but these are just helpful links to further information, documentations, the Python docs, various tutorials I recommend for starting in Python that are a little bit more thorough. Some of the links I provide are to what I consider like really well built tutorials, where specifically my favorite that I recently found, I wish it was around when I started on Python, was not that one. Ooh. Yeah, learnpython.org, which is really cool because it's a walkthrough tutorial, and it has a sort of interactive interpreter you can play with. It's not entirely raw Python, but it emulates Python capabilities, and you can run it, and it will. And if your code doesn't match it, it'll say, "Here's the output we expected," and it's a walk along too. It's really useful, really fun. If you want to speed through this, if you're more familiar with other programming languages, this would be really useful. I loved it. I actually went through most of this and really enjoyed it. They actually got other languages for that too. So my contact information, if you have any questions at all regarding Python later on, or if you have any questions about the talk that you don't address during the tutorial or afterwards or whenever, my website is yano.me. And it has my contact information listed on there. And my GitHub is github.com/myano. Let me pull that up. Yeah. My gists, which is like GitHub's page site, has this here, which is the link that starts off on what I consider like important topics with the tutorial. Like the big burning question on everyone's minds is, are we doing Python 2 or Python 3? Because Python 3 has been out for a while, Python 2 has been out for what feels like forever, and there's various quirks and differences between the two, and benefits to using one versus the other. For the sake of sanity and for simplicity for this talk, we're covering Python 2 instead of Python 3, mostly because a large portion of standard libraries or libraries out there and programs that currently exist are still Python 2. And the default Python version on most Linux distributions or Unix-like distributions is still Python 2, unless you run Arch Linux, where they've completely gone to like Python 3, which caused somewhat of an uproar because they didn't port everything. That was an interesting history moment with that distribution to watch. So this is the main reason why I'm covering Python 2, specifically Python 2.7. Most of the stuff I talk about is not that different than previous versions. So most of the basics you can run almost any Python version. There's actually a list on the official Python docs about where they list differences between the two. So when you learn Python 2, and let's say you make the jump to Python 3, it'll say, look, well, here's what's changed. Here's what we changed. Here's how things act differently. Python 3 does make things easier, but it's people are moving to it. It's it's a fun philosophical debate to have, but it's interesting enough. So this tutorial we're covering Python 2. Specifically, I'm running Python 2.7. Most stuff that's going to be covered, we're working pretty much any version of Python, like 2.6 previous, maybe not before 2.4, but if you're on at least a modern version of Python, you should be good to go. How's the font size on my terminal? Can everyone see it sufficiently? Is it too small, too big? All right.
The size is fine.
Okay. Yeah, the colors aren't going to matter in about a minute once I actually get into Python. That's just my prompt. So, let's see here. All right. What is Python? It's a programming language. It was created by Guido van Rossum. I can never pronounce his name correctly, but it was created back in 1989, or that's when it started. That's when he first conceived the idea, and he started building it. And it launched into, well, today, like a full-fledged programming language. Most people consider it a scripting language because it's usually used for making quick and dirty hacks rather than building full-fledged software out of it. But it's got an intricate history. Not too much I'm going to go into detail about, but a lot has changed. And fortunately, we're at an interesting point in what I consider Python's history of watching how Python 2 and Python 3 span out, considering 2's, they haven't marked an end of life for it yet, so it's still supported. They're still putting features, backporting stuff from Python 3 into Python 2. So unlike other programming language versions where they, say we're end-of-lifing this and you have to move on, Python 2, Python 3 still coexist very well together, as from the official standpoint. So let's dive right into Python. If you're on a Unix-like system, and I encourage everyone who's got a laptop who has a Linux-like distribution to follow along and run the commands. Most of the code I have, I'm either creating live, or I have a few scripts I've built prior to talk, mostly just for the sake of like having data to play with effectively. Like I have, let's see here. I create like a fake data pie, which is just basically a list of colors and some profiles and stuff, and we'll play with this later on, but it's available on my gis.github.com/myano, and it will be the file name fake_data.py. You don't really have to understand what this code's doing right now, but if you're following along, you're going to want to download this, and because I'm going to be calling this later on and like looping through data and doing some stuff with it. So I'm terrible thinking of examples off the top of my head, so that's kind of why I pre-built this. And my philosophy for tutorials is I prefer to do stuff live rather than having too many things pre-built. Like I have, about 8 pages of an outline of stuff I want to cover, but I prefer to show Python an interpreter live as if you're following along, because that's what I think is one of the more effective ways to learn, is actually doing the Python rather than just taking notes or just watching me do it. So this tutorial has no slides or PowerPoint presentations. There's none of that available because I'm not a presentation guy. I'm not a PowerPoint guy or slide guy. I prefer to actually show code and actually run and actually get people interactive, which leads to my second thing. If at any time you guys have any questions all about what I'm running or what I'm doing or something just doesn't make sense, feel free to chime in with a question. If I feel like the question might take too long, I might say wait till a certain point, because there's quite a bit I want to cover, even though it's only Python 101. The goal of this is I want to have you guys understand enough basics to start writing applications or writing quick scripts. Like if you have like a quick math problem you want to solve, you should be able to solve it in Python by the end of this tutorial. If you have an idea of how you want to solve a word problem involving math, where it's a little bit more complicated, where you might have to do multiple calculations at once and handle data differently, that's something you should be able to do after this as well. So we're going to, for the people who are familiar with the program, we're going to go up to a point of, like I said, just before getting into classes. So pretty much a lot of stuff before that. So at least that's my goal. I always try to shoot for much more data than I could probably actually ever cover, but at least I try to cover as much as possible. But yeah, if at any time you guys have any questions, just feel free to chime in. So if you're on what's considered command line on a Linux type system, or quick thing, if you're on Windows, you can run Python on Windows. You can download Python, you can install it, and you can run Python code on Windows. In my opinion, it's not the easiest way to do it, but it is possible. I'm not familiar with doing it. I haven't done that in years. I've only done it once. But if you're on a Linux or Unix-like machine, I can help you more with that. And actually, I spent the past week trying to get Python to work on, or well, not Python. Python comes on the Mac, but I did some installing of IPython and a bunch of stuff on Mac, so that was a fun adventure. But if you're on a Unix-like system, the quickest way to just jump right in, if you already have Python installed, which it most likely is you simply just type Python and you're in the interpreter. Yes?
What's Unix?
What's Unix? It's an operating system that was created back sometime in the 70s. I believe by Xerox or Berkeley, or no, that was BSD. AT&T, yes. And it's, yeah, Bell Labs. Yeah, it's an operating system that is, I'm trying to think of a good way to generalize this. It's hard to describe in like a short sentence, but it's pretty much a grandfather of most modern operating systems. Mac is derived from it. Linux is pretty much derived from it, and even arguably you could say some parts of Windows is, but that's a bit of a stretch there. But it's an all-purpose operating system, just like Windows. It's probably not as graphically user interface friendly, depending on which distribution you use. Yeah, but you can, the most common Linux distributions, which is a more popular form of it, are like Debian, CentOS, Fedora, Ubuntu, Linux Mint's the new popular one now. Linux Mint, Ubuntu, and Fedora are more your user-friendly ones you just install on a laptop and run with. But yeah, so that's Unix, and Python comes with them all. Because many modern packages have it. And if you're on the command line and you just type Python, the prompt will pop up. So the interpreter. This is one thing I love about Python versus some other languages, mainly Perl. Well, you can do some Perl, but it's annoying as heck, is if you're learning a language and you want to try a bit of code, like you're kind of not sure how it works, but you want to play around with it to see how something behaves, the interpreter allows you to do it without having to actually create a file. You don't have to create a file, run it, or compile it. It's an interpreter. It effectively runs the code live. There's a lot more going on in the background in terms of bytecode and things like that, but it's more interactive. You could just throw stuff at it. Unlike C, you can't really do that. You can't just bring up an interpreter and write code and have it instantly show you the results. You have to say file, compile it, and everything like that. So when you get the interpreter open, one of the most basic examples that you see in almost every tutorial you go through is a simple hello world, which is you just print a string called hello with the phrase hello world, which in Python 2 it's just print and then whatever you want to give it. Let's see here, the white's not showing up. Good, yeah, that's because I'm having trouble seeing it too. Yeah. So in Python 2, print's magical. It just works. In Python 3, they made it a real function. So if you did this in Python 3, it would be that. But that's it still works in Python 2.7 because they backport stuff from Python 3 to Python 2. So hello world. And that's your string. So simple enough. Just throw stuff at it. quick thing, the 3 dashes just indicate where you're at. So you can, if you put nothing there, you can keep going and it won't print anything out. So what else can you do on interpreter? Like what stuff you see in code? Well, usually you're dealing with math. So let's say if I had 3 divided by 5, which, and this gets into fun caveats as well. In Python 2, since I'm actually just giving it integers, I'm giving it integer 3 and integer 5, it gives me a result of an integer. So that's why 3 divided by 5 is 0, because it's actually doing a division and then it rounds down into an integer.
So then if you do 5 by 3, would give 1?
Yeah. So 5 divided by 3. Now the trick around this though is if you only make you make one of the variables a float type, and you can now it will actually return what you'd expect a float. So that's a little bit simpler. Well, it's a little bit. It's complicated at first because you'd be like, why is 3 divided by 5 0? Like where it's coming from? But all languages have their own little quirks about things like this. Python 3, I believe this has been fixed. They default to float, I think. I'm not sure. I'm still learning Python 3, so that's another reason why I'm still doing Python 2 for the talk. Hopefully next year I'll be spending Python 101 and it'll be Python 3, hopefully. See how far I get to that in a year. One fascinating thing about Python that a lot of people come from other languages that might find annoying is code blocks. Like if I have multiple lines of code, or in one logical sense, how do I, let's say for example, C++, PHP, you have curly brackets and enclose one large idea, like loops or statements or if statements, conditions and stuff. In Python, it's all about indentation. You indent every line that's supposed to be part of the same logical code block.
Sort of like one of those nested dolphins, and indent farther in.
Yeah, you'd keep indenting further in, which you can get some pretty crazy with indentations. But the general idea is, according to what's called the PEP8 standard, is you want to wrap your lines at 7 characters. The PEP8 is a standard that was written by the Python community about style correctness, of how to make your code look good, effectively make it readable by lots of other people. So it's one of the things is you want to limit your lines, don't have long lines. The other thing is you want to use spaces and not tabs when you're writing your code. But the Python interpreter is very flexible, so if you actually use tabs or you don't use 4 spaces or use any indentation, as long as you're consistent, Python doesn't care. It will still process it for you. Just make sure you stick with the same thing. Most text editors will stick with one of its own conventions. But yeah, so going in with that goes into what scope is, which is, well, actually I'll hold off on that when we get to the more complicated code blocks. But yeah, so back to the types, yeah. So we touched on integers and we touched on strings effectively, which is the hello world, the string of hello world we printed out. Many of the basic types in Python are somewhat simple, at least in determining, like they exist cross languages, well, most modern languages, except for maybe C, because C's, they don't do anything too fancy. So like besides strings and integers, you can also have what's called a list. And they also have, which is basically an array. It's a sorted, it's a sorted array. So it's in order. There's a first element, there's a second element, and there's a third element. In most programming languages, we start counting with the 0 element. So the first element would be 0. So if I wanted to, well, actually I shouldn't have called a list, but we'll do this real quickly. So 2 things about what I just did is I create a list called myList, and I use what's called a built-in function called range. And there's a bunch of built-in functions that are listed on the Python docs that magically exist globally. And a few of them are like length, range, not technically print. And these allow you to apply to most objects. So you can basically say, well, with range, I could give it, 2 parameters, count from like 0 to 10, and it'll just spit out a list. And it'll give me those numbers. So it's a quick little way to give me a bunch of data without having to manually input it myself. So I got a list of numbers from 0 to 9. Now, what's interesting about a list is, since it's like an array, most data types, well, I shouldn't say most data types, but other data types inherit some properties from a list. So back to our hello world example, let's say we took hello world and we saved it as a variable called myString. Oops. And I print it. But now let's say I wanted to manipulate it. Like I want to change something in it. So one interesting thing you could do about a string, well, actually, let me back up. For the people who've done C before, this might be a little easier. What really is a string? It's
ordered inside quotes.
Yeah, but more lower level, it's an ordered list or ordered array of characters. Like you could break it down to smaller elements. So like in C, there's the joke, if you don't put a null terminator at the end, you'll have a bunch of garbage because it does know an end. But in Python, strings are a little bit more flexible, and everything, in my opinion, breaks down to a list. So in Python, you can technically think of a string as a list of characters as well. So I can play around with this if I wanted to. Well, actually, that's another thing. So type is another one of those magical built-in functions. And if I give it any object, it'll tell me what type it is. So if I wanted to prove that the variable myString is a string, I could have it output it's a string, or str. Now, if I wanted to listify or make the string a list or print out what it'd be, you can do list of, or, yeah. Yeah, okay, so, yeah, that's why. So, like I said, strings have some properties of lists, but they're not entirely a list type. So to prove that my list is a list, I do type my list and it comes up as a list. But with my string, it was a string, but the cool thing I could do is I could use what's called an accessor. And with strings and lists, you're basically calling specific elements inside that string. And in Python world and most programming languages, you start with the first element in anything as being what's called the 0th element. And then the second item is the first element and so on. So you can also do this with lists. So like I can take the first, and so basically what I'm saying is the part before the colon is where you're going to start counting at, and then the part after the second colon is where you're going to stop counting at. And then -1 part is a little bit of Python magic that lets you count back from the end of it. Yes?
Hey, just for people like myself that are really new to it,
Mm-hmm.
To put Python into context, what type of programs can you make with it? Like, can you do website stuff? Or,
yeah.
Because I don't even know what the limitations are.
Okay, so the question was can you build websites with Python? Like, what can you do with it? Python is very powerful. Like any language, you can solve any problem because it's Turing complete, which is a little bit more of too complicated of an answer. But yes, you can do web stuff. It is very web friendly. There's frameworks. One of the most popular ones is called Django, which allows you to build a website. It's basically like the Python Ruby on Rails for people who are from the Ruby camp. You could build websites with it. You could build scripts that handle files in operating system. You could build daemons. You can build pretty much anything you want. The nice thing about Python is there's a lot of libraries that exist out there that aren't part of the standard library that you can pull in. For example, if you want to build like a GUI interface locally, there's WX, there's PyQt, which are basically frameworks that allow you to generate that build the windows on the screen itself. So the nice thing about Python is a lot of stuff's reusable, and a lot of people have already built it. And that's another reason why a lot of people are still stick with Python 2, is a lot of the stuff that already exists is still in Python 2. Not many people have ported it. Google uses Python a lot in their help pages on their website. Like if you ever go through their documentation, you'll see their URLs with the .py, and they also have because you can use Django, you can use Flask, you can use like a CGI type thing to render pages. There's a lot of different ways to build web stuff with Python. We could probably spend like 6 hours arguing over which one's the best one, but yeah, there's people have their preferences with that. But you can make as monolithic of a program as you want with Python. I don't know if that's such a great idea, depending on what you're trying to accomplish, because my idea is like try to use a language that A, you're familiar with, and B, that can probably get the job done in the easiest way that you're familiar with. So, but yeah, the power of Python, it's phenomenal. Like, there's lots of stuff out there. And the Python standard library itself, which is the stuff that comes with Python, is phenomenally huge too. But yeah, and I'm going to be covering some of the stuff in the standard library towards the end of the tutorial, so stuff you can pull in. But yeah, so back to the lists and strings. So with strings and lists, you can, to cover what we were on, it's an accessor, which allows you to access specific elements at specific positions. And what we're doing is we're calling those specific positions. So if I wanted the first element, I do my list 0, and it gives me the 0th element from there. And if I want to call the 4th element, I'd get the 4th element. Yeah, okay, yes. This is actually a bad example because the elements in the list are the same as their position number, which is, I didn't think about that. But if let's make a new list. We'll say we'll do 25 to 35. So now my list is the numbers 25 through 34. I'll increment by 1, and I wanted the first element. I get 25. So the colon allows you to define a starting point and ending point, and this works for both strings and lists. So strings and lists share a lot of properties together in this sense. So you can do some magic, like I want from the second element to, let's say, the second to last element. So the negative number just says start counting from the end of the list backwards. So it's somewhat simple. You can do some crazy things with this, like with large and complicated lists. Another cool thing you could do is you can use what's called, I think it's a skip, but effectively I could say from the first element to the last element, and I want to do 2. So what this crazy stuff does is I started at the position 1, and I went up to the last position, and I counted every other element, every 2 elements. Well, it was every other element, yeah, the number. But yeah, so if I put 2 in there, the number after the second colon defines the spacing between the counting from the first position to the second position without going past the last position defined.
By default, it's just 1.
Yeah, by default, it's 1. So you could think of that would be equivalent to this. So the colon 1 at the end is assumed. And you could do some crazy things with this. Like you do, there's depending on what's in your list, because I should probably cover that too. A list doesn't have to have all the same type. You could mix and match stuff. Some languages, I think, force you to use a specific type. So conveniently for this example, I have a bunch of integers, but I can say I got a new list, and I could say I want A, I want 1, and I want foo. And if I print a new list, I have mixed types. Now, what's the difference between lists and strings is lists, I can change stuff inside them. I can assign stuff to accessors, but in strings, I cannot. So for example, let's say with my list, which is 25 through 4, let's say I want to change the first element to something else. So now if I print my list, that element's changed. So I could change it as I go along. However, if I go back to my, actually I forget what the variable's called, say greeting would be hello world. So if I had greeting and I want to change the first element to, I want to change the H to, let's say, G, it's not going to work because strings don't let you do that. And what this is called in programming is called mutability. Strings are what are called immutable, and lists are called mutable. And basically that's just a fancy word for meaning you could change stuff inside of it.
Because you can mutate it?
Yeah, that'd be a good way to think of it. So it's nice, it's dynamic, there's quirks if you're not familiar with it, but strings and lists do have quite a few similarities. Strings do have functions available off of them. So with my greeting, which is printing hello world, I can make it all uppercase. Have it yell at you, say like hello world, and do dot up, and it'll print that. But it does not change it in place. So it's returning that new value, and then I can send it somewhere else. So these functions are not changing the variables in place. They're giving you back something new, and then you can send it to a new variable. Basically, it's trying to be non-destructive. Yes?
If you wanted to change it, you could put greeting equals greeting dot upper.
Yeah, you basically reassign the variable itself. You can do that, but that's you can do it that way. So what he was saying is you can do something like so now I've changed it, but basically you're just reassigning the variable at that point. So it's kind of cheating, but so which that brings up another thing. The way you concatenate strings is with a plus sign. Basic math operations work. They just work on most data types. So, for example, and this blows some people's mind because it's not consistent with some other languages. Let's say if I had a string of, let's say, the number 3, and I multiply the string by, let's say, 20, I get 20 I get that string repeated 20 times, which is nice and annoying. It's nice because it does what I would expect compared to PHP, where it actually try to take the number out of the string and then multiply. PHP's got some weird type stuff where it does some magical stuff. Anyways, I deal with PHP at work, and it kind of annoys me. It's not as fun of a language like Python. But yeah, so that's a little quirk there you can do with that, which is really nice. Also, other things with strings is you can, I wouldn't really say it's the other kind of operation. So let's say the equal thing. So I have greeting, but let's say if I want to add something to the end of greeting, assign it to greeting. We could use his example and say we want greeting equal to greeting plus, let's say, hello world, and say foo at the end. So now greeting is those two strings together. Now, what's really cool is you can combine the two operations at the same time into one operation. So you can redo this as plus equal. And now what the plus equal is doing is it's taking the variable, saying I want to take its current copy and add whatever else it is, and then reassign it. So you're combining two operations into one. And this works for multiplication, and so like I could redo, let's say the 3 we'll say equals 3. I could do multiply equal, say 35. So now A is 35 copies of the number 3. So I could do multiply is equal. So it's kind of like a combined operation on that. And this works for strings, lists, anything that they can add to. And for the sake of sanity, we're just going to stick with strings and lists on that because you can do operator overloading on more complicated data types. I don't believe so. Yeah, it'll just clear out the list. So, yeah. But, yeah, you can multiply by a negative number. The other common thing about strings and lists is, let's say if I broke down a string to a list, or if I have a list of a bunch of characters, but I want to put it back into a string. So let's say if I had, let's say foo, bar, and bat. All right. Yep. I need to close my string. So I got a list and type list. It's got foo, bar, and bat. But now let's say I want to combine those 3 together to make a string. So it's not just those 3 elements. You could try doing, the one common thing you can think of doing is I want to take the object and I want to force it into a string, which it does that, but it takes the literal output of a list and makes that a string. So now my output is a string of a list, which sounds weird. So if I did type of string event, it's a string, but if I print that, I'm literally, well, actually, this is a bad way to display it, but string event, which is another one of those built-in functions where you can force objects into that type, and if it doesn't work, Python yells at you. You can do this with lists, dictionaries, and stuff, and throw stuff into it, and it should work if the stuff you're throwing into it can be transferred into that. You can commonly do this with strings and integers. So if you had, let's say, I want the string of 3. It will take the integer 3 and make a string with that, which is kind of easy to do. But let's say if I want to go the other way around. I have a string from, like, let's say, user input, and I want to, I want to make that or actually, that's a bad example. I can make that an integer because, well, float's not an integer. But anyway, so now I've made 25 an integer. So if I did this type of it's an integer. So I've force typed it. Sometimes useful, sometimes not. There's a whole argument if this is Pythonic or not. We can spend all day arguing about that, but which kind of, it's sooner than I wanted to do it. But quick thing about Python rules and the PEP8 and like what's considered standard in Python. If you do import this, it's a little Easter egg. It prints out a little bit of a help thing that talks about the way you should do things in Python. And this is kind of a slight jab at Perl because of Perl's ideas. There's more than one way to do it. Like we can change strings. We can do anything in infinite number of ways. In Python, we try to have only one way to do it. There's a preferred way to do something. You can do it in other ways, but it's not as unPythonic. Which, you can argue about these all day too. So strings and lists, they're pretty common. They're really useful. You could do a lot of things back and forth with them. But the example I was getting to is, let's say if I had hello and I had world, and I have this as my var. So I have a variable called my var. It's a list, and it's the elements hello world. But now I want to combine that into a string so I can print it or do something with it. In Python, it's not really a clean way to do it, but it's a way to do it. What you do is you create an empty string, or you create a string with a space or however you want to delimitate, and you do a dot join on it, and you add that variable in. So what's happening now is you're creating an anonymous string effectively, and you're joining on a list. So it's going through every element in that list and then basically adding that to the string and then spacing with whatever it is. So if I change the space up here to a plus sign, now that's what it's adding between each element. It's not as clean as some other languages. It looks kind of funky and it's not as intuitive, but that's the way you would take elements from a list and throw it into a string. The other thing about lists that you can do, and actually I should back up a second. Part of those global magical functions that exist, there's two ones I find extremely helpful. There's dir and help. So if you're playing with a bunch of data objects and you have I don't know what to do, you're like, what can I do with this object? I don't know what I can do. First thing, you can always do help on an object. So my var, I do help on that, and it brings up what type of object it is along with what I can do on it. And every one of these lines where it's like x double underscore, or even if we go further down, length, well, ignore the double underscore stuff for now, but like the append, the count, extend, index, the way you read this is those are methods on that object. So I could do any string dot those methods and provide that the parameters listed in the help documentation and get that information back, or it'll change it in place. It's very helpful. Whoa, sorry about that. Extremely helpful, and whoops. Is that okay? All right, sorry about that. Hit the microphone. So it's extremely helpful when you're dealing with more complicated data objects that you haven't seen before. It can be useful if you're trying to read someone else's code and you're like, I don't know what the heck this is doing. Let me go in there and see what I could do on that. The other thing is, which is kind of a more condensed version of this, is dir. So I can pass it that, and this just gives me a list of all the methods and functions on that object. So I could do my var dot sort, and now my var is sorted. Well, actually sorts back down because that could get really complicated quickly. You can change the sorting algorithm and do a bunch of stuff, but you can also do dot reverse, which I believe is a new thing in Python 2.7 or 2.6. It hasn't always existed because before you'd have to actually rebuild the list, which was time consuming, especially if you're dealing with a large list. Dot append, dot count, dot extend, dot index, dot insert, dot pop, dot remove are really awesome and allow lists to act as different things. Like you can use a list to simulate a stack, for example. So you can, do dot pop and it will remove the last item and give it to you and actually remove it from the list. If you want to add it back into, you do dot append. The dot extend, personally I don't like it, but dot extend is the same thing as append, but it's kind of hard to explain words. Say I have my list again with foo and 34. And I want to add, let's say, 35 to the end because I want to keep it going. So now my list has 35. But say I wanted to add a list to the list. So let's say if I had a list of, 36. Phone cut out? Yeah. Okay, sorry about that. I think I was leaning affected. As what? Oh, thank you. All right. So now what append does is it treats whatever I pass in as one solid item that goes in the last place. All right. So what extend does is it takes, if I try to add a list to it, it pulls that list apart and makes the individual elements of that list into the bigger list. So if I did, let's say, to continue the pattern, we'll say 39, 40, and 41, but we're going to make this an extend instead. What this does is now the list, the 36, 37, 38 is one item in the list. So I can do, let's say, 3, 4. We'll do -4. So the fourth element from the end of it is that list. Whereas when I extended it, it actually broke it up and added those individual elements. So that's could be annoying, it could be useful. Depends on what you're trying to accomplish. Other quick little things is if I want to count the number of 29s, there's 0 because I'm looking for a string, but if I want to count for actual the integer 29, you'll get the number of occurrences in that list, which is pretty useful. You can also do this on, well, first let's greeting. You could also do it on strings as well. So if you want. Yeah, it won't work because the string 37 does not exist as a single element in my list. It exists as an element of a list in a list. So you can go and make this even more complicated and go into what are called like linked lists, and you can have large arrays and matrices. You can have lists of lists. You can have lists of pretty much you can throw in any data type into a list. And just do whatever you want with it. But the key thing about lists is it's sorted and it's mutable, which means you could change it. Which brings up an interesting point is, let's say if I had a list, but I want to force it to never be changed. So I'm making some reusable code, but I want to prevent from being, changed. So what can you do? There's another type called a tuple, which is almost exactly like a list, except it's immutable. You can't change it. So let's say pretty much. So now what I've done is we'll say my tuple of my list. And quick thing is you can combine as many function calls and stuff on one line as possible as long as it's valid code. You don't have to save it as a variable and keep redoing it. So, oops, I'm an idiot. I forgot we're assigning that. Okay, so now my tuple is the tuple of it. So if I try changing my tuple at position 0 to bar, it's going to error out because tuples aren't supposed to be changed. And if I do a list of my tuple, it's going to say it's a tuple. Other things that are useful of this, there's another data type called set, which is pretty much identical to a tuple, except there's two differences. One, you can't have any duplicates in it. It will error out on that. And the second thing is it's you can also do operations on it that you could do on mathematical sets. So if I had one of the more common examples is I had set of my set 1. Oops. Oh, yeah. Probably could prevent myself from retyping that. All right, so my set 1. So if I do, so I got a object that's a set that is elements A, C, B, D, or A, B, C, D. So now what I can do is I could create another set called my set 2 and do C, D, E, F, and now I could do fancy stuff like this. And there's a bunch of union operations where you could do ands, unions, joins. I'm blanking on what they are, but basically there are different operations that go through and return database on it. So like my set 1 and my set 2 with this operation is it's giving me all the elements they don't share in both sets. So it's going through and so if I had like 2 lists, I could make it a set and I could be like, give me the stuff that they don't have in common as one list. And you could do the inverse of this as well.
The system itself.
It could be useful if you're trying to simulate math operations, which leads into another clever thing is many people are new to Python. Let's say if you wanted, what's 3 squared? If you try doing 3 to, caret to the power 2, you don't get what you'd expect because it's doing the set operation on the integers, which is kind of hard to process. So like if you want to do raise integer to a power, you have to do double asterisk, and then you'd get what you'd expect. So that's a little interesting thing about going from, you'd think like, oh, it looks like math. I'm trying to square or raise to the power. You can do that as well. Like 3, it will error out because it's expecting something to be sent to it. So other math operations you can do as well. There's, and it's, what's a good example? Say 3. You can do the percent sign, which is effectively mod, which is the remainder of the integer. So I'm taking 25 divided by 3, which the nearest one's 24. So it's 3 times 6 plus 1 and gives me 1. So there's little operations like that you can pull out from it. That's we could do on strings. You can also do bitwise operations. I took too many notes for this section. I'm not going to cover it because it's, in my opinion, way too complicated for this. But if anyone who's familiar with bit operations, you can effectively do manipulations of that, of transposing binary numbers effectively, which is really awesome. There's like a whole list of like operations you could do on it. And actually, technically, the caret is a bitwise operation. It's a bitwise exclusive OR. But it's, in my opinion, a little kind of, I don't know why I took so many notes in this part, but it's way too advanced for, in my opinion, for doing introductory stuff unless you're more familiar with the math stuff behind that and like what binary is and how binary works and little tricks you can do with like twos, kapas, and other little stuff like that. So that's actually, yeah. All right. So out of the data types I've discussed so far, which is like float, integer, string, list, set, tuple, the other data type, the more missing one that some languages don't have that's really awesome is called a dictionary, also called a hash table in other languages. But effectively, it's an object with key value pairs where I have one element and it's mapped to another object. So the way I do this, I could do my dictionary, and the syntax for it is a curly bracket. So we're going to map A to, we'll say, hold on. Yeah, okay, so another global magical built function is called ORD, or if you give it a character, it returns the ASCII number of it. The inverse of this is char. Now if you give it 97, it'll give me A. Little quick stuff, but the reason I bring this up is so if I wanted to do my dictionary and I was going to map out A to itself, and then we'll do B or, and then we'll do C. All right, so I got my dictionary, and now it's mapped out. The interesting thing about dictionaries, in Python 2, they're not sorted. You can't sort dictionaries. Why would you want to sort a dictionary? Let's say if I wanted to sort it based on the numbers and the value part, I could sort on that. In Python 2, there's not really a way to do that. In Python 3, there's supposedly a way to do it, but in Python 2, there's not an intuitive way to do it. It's really complicated, and it's kind of slightly hackish. But another interesting thing is about dictionaries is the value part, which by values I mean that's the 97, 99, and 98. That could be any object. Throw anything in there. I can make it a list. I can make another dictionary. I can have dictionaries of dictionaries. I can have dictionaries as a list of dictionaries. I could make it a string. I could make it anything I want. You can go as complicated as you want. The only catch is the key has to be a mutable object. So if I wanted to make the A a list, I can't do that, like a list of the letter A. I have to make it a set or a tuple, something that can't be changed, because if you could change the key inside the dictionary without actually changing its simple ways, you'd be overwriting the wrong thing and the dictionary wouldn't magically update, because the dictionary exists separate, or well, it's a terrible way to describe that. It's a way to prevent you from changing the dictionary without the dictionary itself getting confused, effectively, because it's based on when the variables are updated. Because with Python, since everything's in interpreted list, everything's done live effectively. It's effectively running the bytecode. It's executing it. It's the order of when things operate on the lower level changes, and that's one of the reasons why you can't do that. It's a bit more complicated, but probably too in depth for, and I don't fully understand either because I'm working my way towards the lower understandings of Python. But yeah, so dictionaries, you can go as complicated as you want. It's very similar to hash tables, which is just, it's matching one thing to another, one thing to multiple items. The keys themselves have to be unique. You can't have multiple keys that are the same thing. It's like a set in that regard. So they have to be unique. Yeah. So think of it like a mathematical function. You can have as many inputs as you want, but they have to have what's called a one-to-many match. They can't have a many-to-one match, effectively. So you can't, well, that's a bad example because you technically could do that. But yeah, the keys themselves, like I can't have, well, let's explore a little bit on the dictionary. So my dictionary, I can pop an item, I could get a list of keys by doing .keys. I could do view values. I can do a bunch of stuff on it. I could do iter keys, which you don't have to do because that's a cool thing, which I'm about to jump into here after this. So these are operations you could do on. Get is sort of expired with the dictionary because you can do an accessor on a dictionary. So I can say, give me the key, give me the value for the key A, and it returns that. This used to be, before the accessor existed, you do get A, and you get 97. And a quick thing I didn't really touch on, but strings of Python, it doesn't matter if you use single quotes or double quotes. I didn't really say that, but yeah, you can intermix them. There's no logical difference on that, unlike PHP words. Yeah. I'm going to bash PHP too much this weekend. So, yeah. All right, dictionaries, you can do these operations on it. You could do has key. A lot of these are left over, and they don't really need to exist. So, for example, and this, yeah, okay, this is later on talk, but it's really cool and really powerful, and I love this. And so let's go back to our greeting. I have, hello green. I want to see if the word hello is in greeting. I could do hello in greeting. And it logically operates that and returns true because it searches for that substring in the larger string. It's basically substring searching. The more, what you can do with my list is slightly different. So like I want to find the position 27's at. You could do a dot index and I'll give you the position, but let's say you don't even care where it's at in a list. I just want to see if 27's in there. You could say 27 in my list and it'll evaluate as true. So if you want to see if something's in an element without actually having to loop over every single element to do a comparison, you could just say, is it in there? Just, you don't use the verb is. It does exist as a keyword, but not in this example. That's a little bit crazier. Which this goes into Boolean logic. You could do, yeah? Oh, yes?
What if you say none in that list?
I believe that'll return true. No, I don't think it will. Yeah, return false because none is an interesting object. None's a reserved keyword, and it's a type that exists by itself. It's a none type. It's nothing. It's the void. It's there's nothing there. Which you can get into the whole metaphysical discussion of, well, when you declare, let's say if I want to declare a list that's empty with nothing in it, I can just create my list 2 and just call the global function list or why can't? All right. Well, okay, so we'll do it this way okay, so it's not working on this. I don't know why, but the way to create an empty list is you just use square brackets. more proper way to do it is use lists and then the end of parentheses. But for some reason, it's not working on this, and I don't really know why. But that's the more Pythonic way to create an empty list. But if I do a type on that list, the list mylist2, it's a list type even though it's empty. But the fascinating thing is any object that's empty is evaluated as false in Boolean logic. So it's very similar to none type in that regard. It's kind of weird. So like if I did an empty string, I get true. If I did empty string and that, I still get true because an empty string technically exists in a large string. The Boolean logic has weird little exceptions on that. Any language is going to yell at you. Yeah, most modern languages are going to yell at you for doing that. Some languages might yell more, some languages might yell less, but if you do 5 divided by 0, you're going to get an integer division or modulo by 0, which leads to a slight thing which I was going to cover later on, is reading error messages. Whatever's before the colon is the name of the error, and anything after is a description of why it failed. And you can create your own as well. I'll get to here in a bit, but like you can do a assert, which is cool for doing tests. So let's say if I had another object, my object equals 3, and I want to assert that it equals 3. Oops. Okay. So assert my object is equal to 3, and we'll say we'll say 4. So I created my own assertion error effectively, and the description over here pops in over here. So you can basically do testing this way, which can be useful if you want to make sure something ends up the way it is, and if not, you'll raise an exception, which is really useful.
You can create your own error messages?
Pretty much, yeah, that's what it's doing. But the assertion error it'd still be called an assertion error. You can create other error messages later on you'd create your own class, but that's a bit more complicated than I want to get into because I'm not really going in too much into what's called object-oriented programming because that's, in my opinion, a little bit higher. Well, yeah, it's a little bit higher level. The idea of that is everything's an object and you could do stuff on it, which is kind of what it's slightly intuitive, but that's kind of what you pick up on in Python, unlike other languages, is that everything exists and you can run stuff off of it. You have methods, you have functions you can run off of it, and that's part of the OOP paradigm is you can do stuff like that. Which, yes. A couple other, so building upon this, you can do error checking as well with try and except and like do error catching. So let's say, okay. So I want to try, say, do something that's impossible. Say like a equals 5 divided by 0. But if it doesn't work, I could say make a equals 5 divided by 3. If I run it, print a, you get what happened in the except part. What you can do that makes it slightly more complicated is you can have it run except only if a certain error is raised. Yes?
Or at the except, you could say print infinity.
Yeah, you can have it, do anything in except. There's also try except finally, and that would run after the previous two things are done, regardless of which one it ended up in, which you can do some crazy stuff with that. But the triggering on certain excepts is if we did this again, except, and this goes into the indentation for the logical blocks, 5 divided by 3, but let's say if I want to accept on IO error. So what happens here is since I'm for the accept line, I'm saying only run the accept line if the error it receives is an IO error, which is writing to disk stuff, since it's a zero division error, it failed because it failed doing the try part. There's no except the
For a zero division error?
yeah, that's why I cut on zero. There's no except the catch when that fails, so it still errors out in this case. So except without anything on that line is a catch-all. So it doesn't matter what breaks, it's going to catch it. But you can specify specific errors. So if something unexpected happens when you try, you can have an error raised for that specifically. Yes.
So once you explicitly give it a type of error, then it won't catch all. Is there like a default then at the end of testing for specific ones to say, hey, if it wasn't any of those previous 4, then?
That's what the finally would do. So if you try except finally would look the same, except we'd have, whoops. So do try. So what happened here, well, so it's sort of both of them. So it does the finally, regardless of the error, but it still errors out, though. So it executes the finally stuff. So make sure whatever in the finally part does get executed. But it's still going to error out. So it's sort of like a catch-all, sort of not, but it's the finally makes sure that regardless of how logic breaks down, we're going to make sure this part runs. Unless the code you have in the finally block just doesn't work, and that's an error self. And you can nest these as well. You can nest virtually anything in Python. By nesting, you could have a try except within a try except, and you can make this as complicated as you want with more nested stuff. Yeah. All right. So I did that for, but all right. So moving on with the documentation, and one of the I don't know why I did this. My notes over, but so the other thing you do, and we kind of touched on this with the comparisons, is you use if-else statements for doing blocks of comparison and reaction to. You can do for loops and you can do while loops. So we can say if a. Let's go back to greeting. So if we said if h in greeting, say print yes. And that's a basic if statement. If some expression evaluates a true, run the indented code below it. You can also have an else. So you could do if h print yes, else print no. Oops. All right. So what it did for this is it printed no, or printed yes, but you can have the else there to catch if the statement evaluated the false. With this as well, you can, let's say if you want to do an else if, which would mean that I would have a list of expressions I want to evaluate and I want to specifically define them. You can have edges. Do print yes. Well, we'll say we'll do nested here. If we'll do x in greeting, g in greeting. So what happened here is it's first evaluating the first statement of h in greeting. And what's greeting? If I can spell greeting. It has an h in it. So it evaluates the outer if statement as true, and then goes into the nested if statement and says, if x is in greeting, print yes. And I totally forgot what greeting was. and it would have print yes. But since there's no g in greeting for the else if, it didn't evaluate that, so that's why it didn't evaluate anything. I totally forgot what was in greeting. So I'm going to break out of the interpreter real quickly because the interpreter is great for showing small things, but let's say you actually want to build your program and you want to make something more complicated than stuff you're writing in here. The way you would do that on a Linux system here is you create a file and you call it .py. That's the extension for Python. And you basically, we'll go to example here. Go fake data. So the quick structure for a Python file is you need a line that defines where the interpreter is. And this is pound, exclamation point, user bin env Python. It's recommended in Python to use user bin env Python instead of user bin Python. In other talks in our programs, you'll see a lot of people say user/bin/python. Bad thing about doing that is not everyone installs Python in the same place on their system. What this does is it says wherever your default Python version is, we're going to use that. So that way, it's basically preventing yourself from statically calling Python in a specific location, which is bad, in my opinion. And the PEP8 says use this because it prevents that from happening. It makes your code more portable. So you create the file in .py and you give it execute. Well, we won't cover that part, but so documentation is very useful in Python code. So are comments, because you need to explain what your code's doing. In Python, there really is not a good way to do multi-line comments. It was kind of, I don't know if it was an afterthought or there wasn't really, it's sort of cheating. So the way this multi-line comment works is it's a string that just is not assigned anything. And Python treats that as it's just there. It's not going to error out. It's not doing anything with it. We're just going to leave it there. So if you create a string, don't assign it to anything, nothing's going to happen to it. It's just going to magically exist there. And it's the way to do multi-line comments. The way to do single-line comments is your pound symbol. And that comments to specific lines. You can also do comments at the end of a line, and you can also you can do comments at the end of lines as well. So in this file, this is the fake data. If you've downloaded it, it's what we got here is we got a list with the colors. We have a dictionary where we have names mapped to some made-up pages, and then ignore the ranges part there. Then we have a profile, which is a dictionary of a dictionary, which is talking about you can have nested data types. So Alice has the properties age, height, and weight that you can pull up on it. And the clever little way, and I built this first and didn't think about it, is you can sort of generate this where the information is random using import random, because it's a standard library thing that allows you to generate random numbers or make random choices. And so what you can do is you can have it pick random elements from a list or a dictionary or pretty much any data type. And that's what I did. But the problem with that is if everyone downloaded this and ran it, no one would have the same data. Everyone would have different numbers. And that's kind of what initially I was going for. I thought it'd be useful, but then I realized if everyone's running the same code and they're following examples on the board and they're not matching mine, the numbers aren't going to match. And it's just not going to show up. So I hard code the numbers in here. And that's why it's structured like this. The indentation as well was indented this way to make it readable, and it also follows the PEP8 standard of making the code readable. My text editor I'm using is Vim. There's a useful plugin for it that allows me to evaluate my current code and tells me if it's PEP8 compliant or not. You don't need a text editor that does this. It's useful if you're trying to keep your code consistent, but it's nice if you want to have some way to remind you or nudge you saying your code looks horrible, you should fix this, and it'll tell you where to fix stuff. So like if I did something like this, it's still technically valid Python code, but it's going to say continue line missing indentation. Or actually, no, it's not valid. Actually, that's a bad example. So valid code that would not work would be if I changed that. So it's still valid. It's indented, but There's other things. That's a bad example. But the PEP8, is the documentation that tells you how to write your code, so it's consistent in the layout of your data and how you write your code.
So it looks pretty.
Pretty much.
It doesn't look like a giant word.
Well, yes and no. The later part is hard to define, but I'm going to skip that for now. But it makes your code consistent. Okay, so what you can do, that's an example. You can remove that space. It's still valid Python code. It'll still run, but PEP8's like, no, you need to have a space after that colon in order to, so it reads on the ISBEAR. So you put that there. But yeah, so if I run all that code, I didn't go all the way to the bottom. So down here, this is more advanced. You don't, okay, so like a tad bit of complicated code. Basically what it's doing is it's saying if you run this code from the command prompt, just print this string up here. That's effectively what that's doing. The reason it's doing that is because I can import my fake data. And now that stuff inside fake data is available to me. So now I can do fake data.color. Is it color or colors? I can do fake data.colors, and now the dictionary in that file is available on computer, which is pretty useful. And you can, pretty much any .py file you create, you can import into other .py files and then access that data that's available into it, whether it's variable names, function names, class names, you go crazy with it. You can also do, it's not recommended, let me rephrase it. So you can do from fake data, import colors. And what this does is it changes the level of how I refer to something. So now I'm calling up colors to fake underscore data dot colors. It's changing almost so I can access it without a bunch more inflated stuff. The bad thing about doing this, though, is if you're importing a bunch of stuff from various files, if two files just happen to have the same name, you're going to have conflicts. One file, the last thing you import is going to override the previous thing you import if the things inside of it share the same name and you're importing it in this fashion. That's why you would the preferred way to do this is you just import fake data and then pull everything off of that name. Now, let's say the file you're importing is long-winded and you're like, I'm tired of typing fake underscore data. You can import that as, let's say, just D, and now I could do D.colors. And just create a way to import it. Pretty much locally inside that file or wherever you've done that at. So it's useful if you have something that's long-winded and you're just tired of typing the name of it. It's kind of useful. I tend to do this for a module called datetime because I just can't stand typing out datetime all the time because it's so long-winded. But that's another thing we get into. So let's get back out into the actual files. And we'll go into functions here. So the way you create a function of Python is you say def, the name of the function, and then whatever you want to pass to it. For this example, this is a little bit more complicated. Probably should have done this one, but the first position variable is 1, the second one's 2, and then I have args and quargs. That's probably a little bit more complicated for that. But now what I could do with that is I can say multiple args and print that, actually it's going to print inside the function. So if I run it, and this is how you run Python code, just Python then the name, and I had a misspelling there. Yeah, Python will yell at you if you have misspellings like that, and that's what print. Ignore the args and quarks part because that's a little bit more complicated, but that's the base idea of a function. You can nest functions within functions. Functions also do not have to return information. Unlike, I think it's like C or something, or some other languages where functions have to return something, like they ultimately have to give something back. This is almost effectively a procedure because I'm not returning any data. I'm just printing it out. I'm calling the function and it's doing that. I'm not sending information back. So if I wanted to capture whatever is being returned by it this way, it's, or well, and then print A, it's a none type because nothing's being returned by the function. So that's sort of, I'd say, not entirely clear sometimes, or not entirely intuitive. The other thing about functions, and I got into an argument with someone about this, which I don't really understand why, but so let's say if I import let's import functions. So what happened with this is it ran the code because I don't have anything, because I called the code and it executed. But now I could do functions dot multiple args. We'll give it 3. Well, that's because it's expecting 5. So now I gave 2 variables and I could call it. But let's say if I want to reference the function. If I don't add any parentheses to it, what's returned is where it's at in memory. Go into pointers and stuff, which is a little bit more advanced. Apparently in other languages, if you do this, it runs the function. I don't know why. I think that's stupid, but there's a language out there. I forget which one it is, but I think it was Ruby or something. Someone said like you could, if you run a function without the parentheses on it, it executes the function. It doesn't give you where it's located. Is that true?
It's not necessarily true.
Okay.
It's Ruby appends parentheses in the background.
Oh.
But if you use it as, I think you can assign, you can create an object or a variable that holds a function.
Okay.
So it's different.
The brackets. Oh, the number is just its position in memory, which is just, it's like an address book you have. You have numbers and then whatever's stored in it. It's a little bit more complicated than I want to get into, but that's basically what pointers are. And pointers don't really exist in Python, so per se, if you're more advanced in programming. But yeah, so with functions, what's useful about this though is I can now say create a variable called my, and I could do my, and now my is now a reference to that function, and now I can use that. Basically create, it's not a copy of the function, it's just a reference to the function. You're basically creating a new name for it. If you want a copy of it, and this is more of import stuff, there's no nice way to copy stuff in Python, which is kind of crappy, because if you wanted two things to actually exist without, well, let me do a more simple example. If I had a equals 3 and b equals 5, and I did b equals, well, actually, we'll just do it this way. A equals 3. B equals A, now we're going to say B equals 5. What do you think B will be? Or what do you think A will be?
3.
Wait a second. Yeah, so, oh, I got it backwards. So, all right, A equals 3, A, B equals 5. Oh, yeah, I got it out of order, yeah. So, B equals 5, and A equals B. Yeah. Yeah, so what's happening is I'm creating a variable called A, assign number 3 to it. Then I create B, and I create assign 5. But then I'm going to take A and assign it to wherever B is. So now A is what, oh, wait, I don't think okay. Hold on a second, I'm getting this out of order here. So A equals 3. Yeah. A equals 3, B equals A. Yeah. Okay, yeah, so it's, don't know why this is, yeah, okay, so what I think is This might be with Python 2.7, but one problem, this used to be a problem, and apparently it's not. The idea is, oh, this would be better with lists. Okay, so we'll do, all right, so A, B. All right, now if I do B equals A, and then do B0 equals foo, then print A, and then print B. What happened here is B is a reference to A. So when I change B now, it's changing A. So this is what I was trying to demonstrate. It's not creating a copy of when I did the assignment B equals A. Because so there's a clever way to do this. You can say C equals B, and you just put the colon with no parameters. And that basically gives you a copy of it. Now I could say C0 equals bar, and print B, and then B didn't change. So that's one way to do it. Then you can do copy. Copy.copy is the more verbose way to do it. With strings, you could, or with lists, you could do the colon without parameters on each side. But yeah, Python, you can't, there's no nice way to copy stuff. It depends on the data type. Copy.copy is not type specific, so it doesn't matter what object it is, it will copy it for you. Oh yes, okay. Before I forget, because I missed this last year, because I get interested about various things. Loops are important. So the coolest thing in Python, and a lot of new people like this, is the for loop, because you can do fun stuff with this. So we got fake data, right? So, well, we got colors. So I got my colors here. We're going to say fake colors equal to, we'll just say colors because I'm tired of referring it to that way. So we got a variable called colors. It's a list of colors. Now, let's say for each element here, I want to append an exclamation point to the end of each string. How would I do that? You can... Yeah, for item. Yeah, in.
Now,
yeah. Well, the more proper way to do this is you shouldn't. Well, you shouldn't overwrite the list in place, because that messes up with for loops. Because in the for loop, because especially if you're adding new stuff to the list you're changing at the same time you're iterating through it, you could accidentally end up in an infinite loop. So you don't want to change what you're iterating through. So the more proper way to do this is, I got new colors, and we'll say new colors, we'll just say new colors equals an empty list. So do for item in colors, oops, and you need a colon at the end here, and then indent to keep your logic flow the same for it, because you're starting a new logic block. We now do new colors dot append that item, then we're going to say plus exclamation point. Let that run, and now we have new colors. So, yeah. So what's nice about the for loop is you can create any name you want and use this in, and it'll iterate through pretty much any object that's iterable. This works for strings. It works for lists, well, sort of dictionaries. That's a little bit more complicated. That's, yeah. You can't, integer is not iterable. No. If you made it a string, you can. If you force an integer to become a string, you can iterate through each character in it. Yeah, then you could turn it back into integer. So you could do force typing, which is another thing is Python, what makes it nice is with all the stuff I've done so far, you never once had previously tell the program what the data type is. You can dynamically change it. And this is why Python's called dynamically typed. Unlike C++, where you have to say, I want an integer, this variable will all exist as an integer. If I try to do anything that's not an integer operation on it, you're going to yell at me. Other languages are like that. Python, we just don't care. We let stuff fly around. You could change variables. They could change types. It's nice. The one thing Python frowns upon in the whole PEP8 and the whole Pythonic knowledge is type checking. You should never, ever have to really type check anything. 2 reasons. It's dirty as heck because the code looks awful, and the other thing is Python tries to go for the object orientedness of having objects be dynamic. So a lot of times the object, especially if you're creating your own objects, they could be anything. They could be anything you want, and type checking can become really complicated. So the way, new colors is a list. Now, if I wanted to create an expression to prove that it's a list, there's 2 ways to do it. There's the more sloppy way to do it, and this works, and I want to say before 2.7, if you're on 2.6 and older, is you do type of list equivalent to type of the variable I want to call. And that would be type checking. Looks terrible. It's not Pythonic, but it is possible to do type checking if you need to force upon it, but it's not really recommended. There's another way to do it. There's a global function in Python 2.7 and Python 3 that I'm blanking on now because you never really need to use it, but it allows you to just give it an object and it does the comparison for you. I think it's only Python 3. Yeah, it's a little bit nicer in Python 3, but the idea is you shouldn't have to do it if you want to make your code Pythonic, because Python, you shouldn't need to do it. It should all just flow together. It's supposed to be dynamic. It's supposed to be fluid, I guess, would be a good way to explain that. Because it has for loops, you can also do while loops. While loops do exist. You probably won't see nearly as much as you see for loops, because for loops are designed to actually iterate over objects and manipulate the data. While loops are simply while given an expression, we'll say n equals 0, while n is less than 5, print n, and I forgot. Yeah, okay, so the reason that messed up is because I forgot to, and this is another reason why while loops sort of suck, is I forgot to increment looping over. So now, the reason this is not recommended is because a couple things. One, you have to actually declare a variable, what you're going to start at, before your while loop. You have to have your expression, and you have to remember to increment it inside the while loop. A more niftier way to do this is you can use what's called list comprehension. It's a little bit more advanced topic, but the way this would look would be you would have n for n, or say x for x, and range from 0 to 5. Yeah, so this would effectively create a while loop for that specific expression, but since this expression n from 0 to 5 is easy to represent and there happens to be a range function, you could do it this way. The difference is the data coming back and how you want to handle the data. But most while loops in Python could be written more Pythonically and with a for loop. You can even do for x and range is 0 to 5 and just, print x. And it will do the same thing as the while loop. And you don't have to create that temporary variable. You don't have to remember to increment. It just does it for you. But this is convenient because the range function exists for this specific expression we're covering. What you can do with loops is you can break out of them. This is useful if you have nested loops within loops within loops. If you want to break out of it, you can simply just use break. And the reason it generates an error now is because I'm not inside a loop. But if I did while true and I said break, it only iterates once because true is infinitely always going to evaluate the true. But the first iteration, break says hop out of it and it exits. So if I did, let's say count equals 0, while true, count plus equal 1, break, print count, it's only 1. So that proves that it only went once through the code block of a while loop. Other things you can do with loops is you use what's called continue, which allows you to immediately skip to the next iteration in the loop. So if you're in something like, let's say n is 0, while n is less than 5, if n is evenly, so what it does is I'm checking to see if n is divisible by 2. I'm comparing the remainder of it to 0. We'll say print n. And then we'll continue. Yeah. Wait, I forgot the increment. Yeah, I keep forgetting to do it. So, yeah, while n is, yeah, well, okay, yeah. So the continue, let me pull up where it's at. I got too many terminals here. So, fib. All right. Yeah, okay, so this works. So the Fibonacci sequence, many people are sort of familiar with that, right? You want to generate, it's basically, the formula is you start with a number, and the next number is the previous two numbers added together. And you start with 0, 1, 1, 2, 3, 5, 8, 13. Yeah, and you just keep following that pattern. It's a very interesting number, or list of numbers. I was showed this last night. This is really cool. It's showing a bunch of things at once. You can do multiple assignments on one line in Python, which is what the a comma b equals 0 comma 1. It's called unpacking variables. So what it's doing is it's taking the first thing and assigning to the first variable, second variable assigned to the second one. So now a is 0 and b is 1. And what this while loop is doing is it's evaluating while a is less than n, and n is the variable we're bringing in. We're going to print that, and then we're going to do some reassignment. Now, what's really clever about this is the way most examples for this work is you have to have a temporary variable, because you add it together, and you sign it, and then you overwrite it. So the more verbose way this would be, you would have a temp variable, let's say C, that would hold the addition together, so you can still use B before overwriting B effectively is a problem. Because what this code really is A equals B, and B equals A plus B. That's literally what that line is. But there's an interesting Python thing going at the same time. If I just did this, the problem with this code is that B is being overwritten. Yeah, B is overwriting itself because so it'd be plus equal A. So, well, here we'll demonstrate. All right, so here is, whoops. All right. We'll say we'll go up to 100 here. So it generated the Fibonacci sequence up to the number 100. So it's 0, 1, 1, 2, 3, 5, 8, 13. But now, my laptop would not like that. So let's change this up to what it literally looks like. And now what happened here is the code's different, because now it's just multiplying effectively. So what's happening now is, well, we're printing A. So B is, so the problem with this is B is being overwritten before it needs to be overwritten.
Put those in the other order.
Well, the way you should be doing this is, because you need B to be the same when it comes around, because if you overwrite it, well, we'll step through this. So we'll print A, print B. All right, so now it's stepping through and it's showing you A and B is 0, 1, then 1, 2, 2, 4, 4, 8. That's a problem, because what's happening is B, the next B is not the B before it. And that's what's happening because the sequence is the previous two numbers added together. So if the way you'd solve this would be you'd have, so there's oops, too many equal signs there. So have it's probably a little bit more advanced than I want to do, but it's a fun topic to dive into. So because the reason, all right, so let's back out of this, comment this out, and we'll focus on what's happening here instead of the Python magic. So it's assigning at the time before it's being overwritten because it's, so B, the new value B is, okay, that's what's happening. So the B here is equaling A plus the old value of B before the value B changes. So you're able to use old value B and then reassign it in the same line. So that's why you do the unpacking. And you're able to access, so this B is the value of B before B is reassigned. It's really, it's Python magic. But Fibonacci, I should have held off on that one there. So last thing I wanted to cover, but I never get to it, is file operations and standard in and out. When you print, it's magically going to standard out, which is what you're looking at. And this is slightly more advanced, but you can easily open stuff in Python. And it's just a dot open and there's so that's, all right. So that's most of my talk. I think I spent a little too much time with data types. But is there any questions? There's a few activities I meant to bring up, but a few challenges I proposed that you can simply write, and they're real fun. I'll show some code for that, is how would you implement length, the length function, that where it would work on any object like length exists. And there's a really simple way to do it. It's a great example for trying to, and you can actually do it using what we've covered, the for loops and functions, and it's really simple. The code's only like 4 lines. So any questions at all about anything I've covered, didn't cover, or I failed to cover? Kind of wrapping it up, but so I hope, yes?
What are your thoughts on homebrew? What are your thoughts on using
Homebrew? So the question is, what are my thoughts on homebrew? Homebrew is an application that allows you to, it's like a package manager for Apple computers on a command line. So if you're familiar with apt-get and yum and aptitude, it allows you to install stuff. My opinion on Homebrew is it's useful. I like it. I just started using it like 2 days ago. I don't have a strong opinion one way or the other. I've noticed a lot of Python quirks on a Mac that I'm not entirely thrilled with. It might just be because it's 2.7.5 instead of 2.7.3, which I'm mostly using. I have yet to figure out if I'm blaming Apple or if I'm blaming a Python version yet, but I'm more likely to blame Apple because this is not my preferred setup. It's just kind of what I ended up with. A couple things before, any other questions? Because I kind of want to have like a little wrap-up thing of like where to continue your adventure in Python. Any questions, burning thoughts? All right. So the files I played around with, the fake data, is available in this link from earlier that I had, the get.io link. and explains my thoughts on Python 2 versus 3. These are links that describe more in-depth specific things that I covered that I didn't want to spend too much time on, which I think I did anyways. These are fun resources to extend your learning. Like there's the Python docs. These are tutorials you can follow through. They're books, free books online you can read through. What Now is a link on the Python website of like how to give back to the Python community. Do you want to contribute to the Python core? Do you want to? What do you do now? You know some basics in Python. Where can you go with this? The other relevant links. This is always funny because everyone always makes fun of Python for making everything too easy, and I think it's kind of required. And you get a lot of jokes with Python about like, it's cheating because the code is usually a lot shorter than most other languages. But in Python 2.7 and Python 3, you can actually run this command. And I'll leave the answer. I'll let you figure out what happens when you run import anti-gravity in Python 2.7 and Python 3. But they actually added in there to go with the joke. But it's Python does make things a lot easier. If you're trying to solve a problem, there most likely exists a library out there that will do that. If you're trying to do a lot simpler. One of my best examples I love of that is I tried writing an application once that sent me something happened, like in a cron job, and there's a Pi Google Voice library someone built that allows me to effectively just send a text message using Python to my Google Voice number. And all I had to have was like some authentication system set up, and it just magically did the rest. And someone already built that, and it's out. So like, your search engines are your friend. Try to search around for a library. Someone's probably already built what you're trying to do. If not, build it and put it on the internet and probably make at least one person happy. I know I do. I create a dynamic DNS per script for Linode. So if you have a Linode, which is a VPS, you don't need to use a third-party dynamic DNS to update your IP address with them. The script will automatically run like in a cron job and update it for you with their API. And so far, I've only had one person contact me about it, which means at least one person's using it and one person's satisfied. So you open sourcing your code, put it on the internet, put it on GitHub. At least one other person's world will most likely find it useful. No matter how insignificant you think your code is, someone will probably find some benefit of it. That's my little spiel for open source your stuff. Open source is great. So. And if you have any burning questions for me personally, on my personal website, I have a contact page. You can contact me via email, stuff like that. If you want to, I wrote some hand cards if you don't have a laptop or anything for my contact information. But I really hope you guys continue on with your Python adventure. Read the Python docs. Learn Python.org. I would go through those tutorials with the interactive interpreter, just play around with it, and really hope you guys go far. I started with Python back in the second year of PyOhio. It was pair programming with somebody, and this is back when it was over at the architecture building, and never looked back since. So it's, meet some people this week and have some fun and learn a new language if you don't know Python already. But, yeah.